Hey everyone, in this video we're going to get TensorFlow Lite up and running on the ESP32 using Platform I/O. So first off, let's train up a very simple model. So I've created a Jupyter notebook here. First off we import TensorFlow and then we'll create a training dataset. So this code will generate a dataset that has two input numbers and a label that is 1 or 0 depending on the expected result. So we can now create a very simple model and compile and train it. As you can see, it doesn't take very long to get very good accuracy. And now our model's trained, we can test it out with some simple values. So we'll feed in some numbers and we can see the predictions here. So it seems to be able to do the job pretty well. So now we have a trained model. We need to export it for use with TF Lite. So this code will convert the model into something that is optimized for running on an embedded device. We need to give the code some examples of what our inputs will look like. So I have another Python generator here that will just generate random numbers to feed into the converter so that it can quantize the model effectively. So that's our model converted to TF Lite. We can now convert this model to C code by using XXD. So we'll jump into the terminal and we'll run the XXD command. So we run XXD, we pass in our converted model, and we send the output to the C file that we want our model to be in. So let's run that. And now we can see the contents of what it created. So here's our model converted into some data that we can now use in TensorFlow Lite action. I've created a simple Platform I/O project and I've copied in the TF micro code into the lib folder. There's a link in the video description to instructions on how to obtain the TF micro source code. And we've also got our model data that we exported. I've added a header file to expose the variable from that file. And I've also created a wrapper around the TF Lite code. So the first thing we need to do is create a model from the exported data. We then need to create an op resolver and add the operations that our model uses. You can just specify all operations, but it's better to actually work out which ones your model needs and just add them. We then need to allocate some working space for the TF Lite interpreter to run, and then create the actual interpreter. Once we've got the interpreter, we can ask it to allocate space for the tensors it needs. And once we've done that, we can get hold of the input and the output tensor. And I've added a couple of helper functions here, so we can get hold of the input buffer and we can run a prediction and return the result. So our main file is very simple. In the setup, we create our neural network class, and then in the loop, I just create two random numbers. I put those into the input buffer of the neural network, then I run the prediction and get the result back, and we just output the values. So let's try running this and see how well it works. So as expected, it works pretty well. So you can see that when the second number is smaller than the first number, it predicts false, and when the second number is larger than the first number, it predicts true. So obviously this is a very simple model. You can train models up to do all sorts of things, but that's it for this video. I hope you found it useful, and if you did, please hit the subscribe button. All the code's in GitHub, the link's in the description. So thanks for watching, and I'll see you in the next video.